Again, we'll circle back to what is the derivative of log functions of other bases later. It's very similar. There's just a little bit, there's a little rule to remember. But let's go ahead and do some examples, just like we did with exponentials, of differentiating in when we have algebraic expressions involving ln. Again, this would be stuff that will appear in your homework. And again, it's going to involve using stuff like the product rule, chain rule, and quotient rule when you have certain combinations. So let's say we had negative ln x divided by 2 and we wanted to know the derivative. Well, again, we could think of this as negative 1/2 times x. This is just a constant multiplier. This will not affect the derivative. So essentially, we could pull out the negative 1/2 and then apply the derivative of ln completely separately. Since we know the derivative of ln is equal to 1 over x, as we talked about in the previous video, this would just be negative 1/2 times 1 over x, or just negative 1 over 2x. And anyways, essentially, a little bit harder than e, but ln of x turns into 1 divided by x when differentiating. Now, if we had a combination of ln x with x cubed or divided by x, we need to make sure to use the product and quotient rules respectively. So here we need to do first d second plus second d first. So first d second would be x cubed times 1 over x plus second d first. Derivative of x cubed is 3x squared, very similar to the previous example. And this would leave us with, well, x cubed divided by x is just x squared. And also remember that the input of an ln function x is not something that you can multiply with a general polynomial. So you can't multiply these together. They will not combine in a way, that you would expect, which doesn't need to be said. It's something that if you're familiar with the algebra of logarithms, you know that those can't work, but a lot of people don't really know that. So it is worth mentioning. But basically, usually how we'd write this is we write the polynomial term first and then just leave the ln x at the end. And again, notice there is a common x squared, which we could factor out, if we wanted to, but at the end of the day, not a necessary requirement. Either answer is totally fine. But we do want to simplify our derivatives when using product, quotient, and chain rule. Now, if we had ln x divided by x, we would need to do low d high. So x low d high, derivative of ln x is 1 over x. Minus, and actually, now that I think about it, I want to make sure, I want to make sure in a previous video I did remember minus, but remember, it's very easy to forget. It's low d high minus high d low. High d low is just 1, square at the bottom, away we go. So this would leave me with x times 1 over x. Well, x divided by x is just 1. So actually this would just leave me with 1 minus ln x over x squared. And again, you can't simplify because when x is within ln, it does not, you can't do algebra stuff with that. It's just sort of its own thing. Don't, like over here, don't mess with it. And let's say I had e to the x times the natural log of 4x plus 1. Here I have a product of two functions. And some of you might be wondering is, can I cancel e with ln? Remember, e and ln only cancel when they're composed in a very specific way. If you have ln of e to whatever, or if you have e raised the ln, those are the only situations which it will cancel. So e times ln does not cancel because it only cancels when they're composed properly. But that being said, I could just still find the derivative by doing first d second plus second d first. So first e to the x d second would be 1 over x. And actually, this is probably something we should think about separately. What's the derivative of ln 4x plus 1? What if I have something other than just x within my natural log? And again, this sort of thing, we need to use the chain rule when differentiating anything else on the inside. Because again, it's the same exact thing. I have a function on the outside and something on the inside. If I want to do this, I can take the derivative of the outside. The derivative of ln of x is 1 over x. So this would be 1 over x, but you keep the inside the same. So the derivative of ln of something is always 1 divided by that something. But again, you also have to multiply by the derivative of the inside. So then I multiply by d dx of 4x plus 1. Derivative of the exterior is 1 divided by the interior. Multiply by the derivative of the interior, that's the chain rule. And derivative of 4x plus 1 is just 4. So what I would end up getting is 4 times 1 over 4x plus 1, which would just be 4 over 4x plus 1. But essentially that would be my derivative of that. So coming back to this example, first d second, e to the x times 4 over 4x plus 1, plus second d first. And since first is just e to the x, that derivative would just be e to the x. And again, we could probably clean that up, but that is good enough for now.